Okay, so this is going to be the second problem that I do. I want to skip over the encode and decode strings because it doesn't really interest me, the problem, but I would definitely should probably look back at it at some point. But for right now, I'm going to go ahead and do the product of array except self. Okay, so let me get my clock set up here. Okay, so given an integer array nums, return an array in it. Array output, where output I is the product of all the elements of nums except nums I. So yeah, I mean, the whole follow up here basically makes this problem a little bit harder because I mean, you could either just do for every single one of these positions, you just do the product of the entire array divided by the given position that you're at. And so this array is 48, the full product. So 48 divided by 2, for example, is 24. 48 divided by 4 is 12, and so on. So it makes the problem a little bit harder. And I think NeetCode has a few videos on the pattern that's basically used for this. It's prefix sum, and then doing the postfix sum as well. So left to right, right to left, you're tracking the values. And so obviously this is going to be product. And so what we want is to have a prefix array where we have a bunch of ones. Have a bunch of ones that the prefix array will be the length of nums. And so we have an array of ones, and the array is the length of nums. And so to calculate the prefix product, what we'll do is we'll loop through the range of nums here, and we want to go ahead and at the index of the prefix array, we want to oh yeah, you know what? So we want to look at index minus 1. And so if we did this loop, obviously we'd have an out of range error where we would be looking at the -1 position. So we have to start our loop at 1 and go to length of nums. And then we'll do prefix index minus 1. And so it would be 1 times 1 in the first iteration. And then, yeah, it would be times nums index minus 1. That should give us a proper prefix, I believe. 1128. So 1 times 1 leading up to 2 is still 1 times 1, so it's still 1. Leading up to 4 is 1 times 1 times 2, which is 2. And then leading up to 6 is 1 times 2 times 4, which is 8. Okay, so there's the prefix array. Now we need to go backwards. And so you have a postfix that's going to be equal to 1. Because in the case of product, we can't have a 0, which is the same reason why we have a 1 up here. Okay, so with that, you want to start at the end now because you're doing postfix. So you'll do for index of range. It's the length of nums minus 1. Then we go to -1. And we iterate by -1. It's the length of num minus 1 because we want to start at this index, and Python, the way that this works, it would actually give us the length of nums, and we don't want that because it would get an out of range error at the end here. So prefix index equals, because prefix will essentially be our result. This is the array we'll actually return as our answer here. So prefix index equals, let's see, well, so we want to multiply it. Actually, we want to do multiply equals to our postfix. So in the first iteration of this loop, we'll go through and we'll say, okay, this is actually addition prefix just for readability. Okay, so it doesn't actually matter. I think about that. This doesn't matter. But the whole idea is that we go to this loop and we grab our prefix, which in this case will be 8, because at the end here, and then we times it by our postfix, which is 1, and then we just return 8. And that's the answer over here, right? And so then we need to update our current postfix and keep bringing that postfix right to left now, just like we do with our prefix. And so we're going to be taking the postfix multiplied by the current number in nums. So we want that. I believe I'll print this out just so I can check it, but I think that is the right solution. Let's see. Okay, yeah. See, I did this problem a while ago, and I kept tripping up around this. But it makes sense when you think about it, is that you have to carry your postfix and keep updating it as you go from right to left. And so as we look at this, our prefix, in this case, our prefix array had a 2 here. And so when we look back, we should be multiplying 2 by 6. And that's how we get this 12. And then we go here, and we should be doing 1 multiplied by 4 times 6. And that should give us 24. And then the same thing is true with 1, because we had also another 1 in this position as well in our prefix array. So 1 multiplied by 2 times 4 times 6 gives us 48. And yeah, that's that solution. Okay, so I think I will go ahead and submit that. Call this one done. Valid Sudoku. Okay. So you are given a 9x9 Sudoku board. A Sudoku board is valid if the following rules are followed. Each row must contain the digits 1 to 9 without duplicates. Each column must contain the digits 1 to 9 without duplicates. Each of the 9 3x3 cell boxes of the grid must contain the digits 1 to 9 without duplicates. Return true if the Sudoku board is valid, otherwise return false. Okay. So our board looks like periods for any empties. Okay. So my first gut reaction is to do Well, so you need to do a hash set, and the reason why is that you need to have um, a hash set per or a set per column. So this is column 0, column 1, 2, 3, 4, 5, 6, 7, 8, right? So you'll have 0 to 8 in your hash set. Those are the keys, and then you have the values of each of or within the set of each. And so then you add it to the set, you know that if you just check it beforehand before you add it to the set, you know that the number is good to go and you're not repeating any values. So that solves like the issue with the without duplicates problem. Okay, so I forgot to do a hash set. Yeah, because this is a set. That's not actually what I want. Hmm. I think honestly collections has a okay, maybe I saw kind of an idea of what Leak or NeetCode was doing. I just don't know where he's pulling it from. I already solved that one. He uses default dict. I don't want to like expose the answer for myself. Default dict. Where's that pulled from? Default dict. Oh, I know what this is. Default dict. If we use default dict and it has like a set inside, what that does is it makes it every value will instantly be made into a set. And so whenever we do something like goals, say test, and we say 1, bring out goals, this will be a set of 1. Yes. Well, that's weird. Okay, I didn't know that's how that works. Default dict. Okay. Okay, but so what I'm thinking is you need to have a default dict for all 3 different cases. And boxes, so boxes, default dict set. And so I think the way you do this is you just do you want to go ahead and loop through the entire board. Is this my, so if I'm looping through this, is this my Y? This is a row. So then I would loop through and I would be at well, you know what? Because it's a 9x9 hard coded, you can actually just do yeah, it's the 9x9 Sudoku board. can actually just do that, which is, you know, kind of weird doing that, but that's okay. So the thing is with this, it's like every key is going to be a, yeah, I mean, if we don't care about these simply just don't matter to us. So uh, if board x, y equals that, then we'll continue. You just skip it just for computation's sake. We won't actually do anything. Then we want to check if the current item, I feel like position equals board x, y, just to make my life a little bit easier here. If current position is in, we want to check if it's in well, we want it to be a tuple. Oh, you know what? This actually doesn't make any sense. Yeah, never mind. Because we want to do if x, y is in equals that's kind of weird. Because like our keys are going to be okay, maybe actually that would help because we want to do this if board xy is in cols, it's going to be a tuple xy, and so and we want this to be true. Oops. Okay, so we want this to be true. Oops. Whenever any of these is true. So in rows x, y, wait a second. No, we don't actually. We only care about the. Okay, let me make sure. So if we're looping through this, this is a row. So this is right. This is right. It's the first one's a row. Or board xy, and this is being very hard to read. Let's see. Here we go. In boxes, and this is where we'll do something kind of weird because the keys are going to be doing integer division. So it's going to be x3, y3. Because it's kind of weird, like the box numbers are going to be 0, 1, 2, 3, 4, 5, 6, 7, 8. And so the way you actually want to figure that out is if, so say for example, this is going to be row 2, column 2. And so in both cases, or actually in our case, it's column 1, row 1, because we started by counting at 0. But in both cases, 1 integer division 3 will give us a simple 0. And I believe that's the case, integer division. Yeah, and then we'll take the floor. That's the whole idea of this, is that if we don't, it taking the floor is exactly how we're going to do this, because 0 to 2 divided by 3 will always give you 0. 3 to 5 in this case right here, so 0, 1, 2, 3, 4, 5. 3 to 5 will always give you 1. And that's exactly how we compute our different squares. So if that's the case, we know we have a duplicate, so we should just return false and get out of this. Otherwise, we're going to simply add our entry into our sets to every single one. So cols.add, I figure how sets work actually. Let me this does not help me at all. There we go. Add set items.add, okay. Oh no, what am I doing? It goes like this. It goes cols y rows x. And we're going to add our current number. Same thing here. Boxes. This as well. And then we'll finally add our position. Otherwise, we'll return true. Yeah, because the way that this works is it's really like each one of these is a row, and so as we loop through it, we know that that's our x. And then once we go into one of these rows, that's our y. So that's the reason why this loop sequence works. And then really, it's just a bunch of like small things where we just skip this and simply do a check for this specific item if it's in these dicts. Yeah, because we're actually checking if it's in the set of that current dict, but we return false if that's the case. Otherwise, we just add it and we continue. And yeah, otherwise we just return true if we don't find this case. And that's the problem, I believe. Yes, okay, sweet. Sweet. In terms of time complexity, this is going to be, I mean, very basic because we have a hard-coded 9x9. So the time complexity, no matter what we do, is going to be O of 1. It'll always reduce down to O of 1. So yes, it is constant time. That's that. Okay. Thanks for watching.